Hi everybody, thanks for checking in. So we have one more strategy for solving systems of equations, and that's the elimination method. So we've seen graphing and we've seen substitution. So elimination method is just the third tool in our toolkit. And so just like with substitution, we can solve a system by eliminating or getting rid of temporarily a variable. And so in order to eliminate a variable, the coefficients of the variable, aka the numbers in front, must form a zero pair. And remember, a zero pair would be any two numbers that add up to zero. So taking a look at example 1 here, I've got 2x minus 3y equals 16 and 2x plus 3y equals 4. And so if I'm looking for that zero pair, if I think about negative 3y and positive 3y, well, those add up to 0. So what I'm going to do is I'm actually just going to add directly here by combining all of my like terms. So 2x plus 2x would give me 4x. Negative 3y plus 3y would give me 0y. I want that equal sign. That equal sign stays there, and then I'm adding 16 and 4 to make 20. Now, the reason that we're really excited about this is because 0y or 0 times anything doesn't matter, right? It's just 0. So we've actually eliminated that variable. All we have really is 4x is equal to 20. And we can solve for x pretty quickly by dividing both sides by 4, and we get x is equal to 5. But you know that a solution to a system of equations is not just one number, right? It is a coordinate pair, an x and a y value. So far I only have the x value. I need the y value still. But luckily, I've got two equations to choose from to help me figure that out. So I'm going to check just using that first equation, minus 3y is equal to 16, and I'm going to use that x value of 5, and I'm going to replace it right here and see what I get for y. So that will give me 2 times 5 minus 3y is equal to 16. 2 times 5 is 10. I need to get y by itself, so I'm going to subtract 10 from both sides, and that will give me negative 3y is equal to 16 minus 10 is 6. And right when I divide both sides by negative 3, I'm going to get a y value of negative 2. So at the moment, my solution looks to be 5, negative 2. But you guys know me, you know better than that. You know we should always check our answers. Something important here is that if we used the first equation to come up with our value of y, we should use the second equation to check. Because if we're checking using the same equation over and over again, we're not actually testing it, we're just going to get the same thing over and over again. So I'm going to replace x and y with 5 and negative 2. So 2 times 5 plus 3 times negative 2, and I want to verify that that does equal 4. So that'll be 10 minus 6, and if I remember correctly, 10 minus 6 actually is equal to 4. So our solution of 5, negative 2 is exactly what we want. So again, this process was made really easy because we were able to very quickly eliminate those y values. So if we look at example 2, one thing we notice right away is we notice, oh, we've got 3x and 3x. That's a 0 pair, right? 3x and 3x, that'll make 0. But be careful. If we add, which is what we'd really like to do, if we stay consistent, we're less likely to make mistakes. If I add those together, I actually get 6x and 6y is equal to 18, and I still have x's and y's. That's not exactly what I want. So what would be better is that if instead of 3x, one of those could be a negative 3x, right? Then we'd have the 0 pair. So just keep an eye out for things like this. This is a really common mistake is to just look at it quickly and assume we've got a zero pair without actually double checking. So how do I turn it from a 3x to a negative 3x? Well, I can multiply by -1. So that's what I'm going to do here. I'm going to multiply all parts of this top equation by -1. I could do this with the second equation too. It does not matter at all. I'm just going to do it with the first one because I can. So when I multiply everything there by -1, I'm going to get -3x minus 4y is equal to -10. Don't forget the other side of the equal sign. And then when I think about combining that with my second equation, now we've got that zero pair that we've been looking for. -3x and +3x are going to cancel out nicely. So we add, again, our like terms. I'll get 0x minus 2y is equal to -2. -10 plus 8 is -2. But really, that's just -2y is equal to -2. And after dividing both sides by -2, we get y is equal to 1. So again, we're almost there. We've got the y coordinate of our solution, right? But now we need the x coordinate. So I'm going to use one of my equations. And when I'm using an equation to substitute for y, I should really go back to my original. It doesn't matter if it's the first original equation or the second original equation, but I should always use one of the originals. So I'm just going to use that first original because it's the one that's on top. And I'm going to replace y with 1. And I'm going to see what I get for x. So 3x plus 4 is equal to 10. If I subtract 4 from both sides, I'm going to get 3x is equal to 6. And 3 times 2 makes 6, so that must mean that x is equal to 2. And so I've got a solution, an x of 2 and a y of 1. That looks good there. But again, I'm not going to let you get away without checking that because mistakes are a totally normal part of learning, and even I make mistakes. So you just want to double check. 3 times 2 is 6, 2 times 1 is 2, and since 6 plus 2 is 8, we've got this all worked out. We're happy. See how easy that was? So just double check and prove we were right. Wonderful. So we can multiply by a -1 to create a negative that we're looking for, but we can also multiply by other numbers as well. So looking at example 3, 3x minus 10y equals -25, and 4x plus 40y equals 20. The 3 and the 4, those aren't going to match up together to cancel out, even if we make one of them negative. Same with the -10 and the 40. But what I could observe is that -10 goes into 40. If this were to be -40y, then I'd have exactly what I need. And so to accomplish that, I'm going to multiply that entire top equation by 4. So what that will give me, 4 times 3x will give me 12x. 4 times -10y will give me -40y. And then again on the other side of the equal sign, don't forget that 4 times -25 will give me -100. Then my second equation stays exactly the same. 4x plus 40y is equal to 20. And by multiplying that top equation by 4, I've got that zero pair. So there is some background knowledge of numbers that's required here, right? We have to think about factors and multiples. But if it doesn't come right away, then maybe play around with it. Just because it doesn't happen instantaneously doesn't mean you're not going to get there eventually. So it's okay. Now I'm just going to add again those like terms. So I get 16x plus 0y is equal to -80. But again, I don't need that 0y. I've eliminated it. Whoops. So I shouldn't use it. I should use 16x is equal to -80. And when I divide both sides by 16, I should get that x is equal to -5. And then again, when it comes to solving for my y value here, I should go back and just use one of my original equations. I don't think I've used the second equation yet in these examples, so I'm going to do that here. Oops, that's just not a y. I'm going to just rewrite my second equation so that I know what I'm talking about. So I'm just going to substitute this x equals -5 for the x there. So I'll get 4 times -5 plus 40, y is equal to 20. 4 times -5 is -20. Plus 40y is equal to 20. I'm going to get those y's, start to get those by themselves by adding 20 to both sides. So I'll get 40y is equal to 40, which must mean that y is equal to 1. So again, according to this process here, I've got a solution of -5, 1, right? X and y pair. But again, it doesn't hurt to check. It really only takes a few seconds. So this time, since I used the second equation to actually come up with my y value, I'm going to use my first equation to check. So 3x minus 10y equals -25. So I'm going to use -5 for x and 1 for y. 3 times -5 is -15. -10 times 1 is -10. And -15 minus 10 is -25, right? We go further in the negative direction. And that's exactly what I want. So my solution of -5, 1 is perfect. I think we need just one more example together. I know most of you are like ready to go, but I think one more example together just to see that we haven't quite covered all the bases. So take a look at these. We've got 5x plus 4y equals -14 and 3x plus 6y equals 6. Now, if you're going through it in your head, you might have realized, ooh, 3 and 5 don't go into one another, and 4 and 6 don't go into one another, so I can't just multiply 1 and make it, You're right. These numbers don't go into one another. Sometimes we have to multiply both equations. So we have to think about multiples or numbers that they both go into. So we could do this, we could focus on either the x or the y values. And there's not just one right way to do this. So if I were to focus on the x's, I might think about, well, 5 and 3 both go into 15. So what would I multiply to make it 15? For the y values, you could make it so that they're both similar to 24y. You could also make it so that they're both similar to 12y. It really doesn't matter. You can focus on either variable. You can multiply both equations as long as you end up right with that 0 pair. So as long as you end up with that 0 pair and you're multiplying correctly, you're going to be just fine. So I'm going to focus on the x's. But again, that's not the only way to do this. So I'm going to multiply my top equation by 3. So that will give me, let's see, 15x plus 12y is equal to -42. I just multiply everything there by 3. Now, to make my 0 pair, I want this 3x not to be 15x, but I want it to be a -15x. So I'm going to multiply by -5 there so that I end up with -15x. And then the rest of this I still have to think about too. -5 times 6y is -30y, and -5 times 6 is -30. So now I've created that 0 pair I wanted, and I can finish up this process. So it might just be good to practice this together. So adding like terms, I get 0x minus 18y is equal to -72. And so really, again, that's just negative 18y is equal to negative 72. And those of you who watched yesterday's video saw that I made a little bit of a mistake here, so I'm going to use my calculator just to be on the safe side. Negative 72 divided by negative 18 is a positive 4. It's a good thing I checked. I was going to say a positive 3. It's a positive 4 though. So we have a y value of positive 4. And then again, when I find my x values, I could use my new formed equations, but it's just a much better habit to go right back to the original first and second equation. So I'm going to use that second equation, 3x plus 6y is equal to 6, and I'm going to substitute 4 for my y value. So that's 3x plus 6 times 4, and 6 times 4 is 24, so not 2x. 3x plus 24 is equal to 6. When I subtract 24 from both sides, I'm going to get 3x is equal to negative 18. And last step here to get x all by itself is to divide both sides by 3, so I get x equals negative 6. So again, according to all my work here, my solution is the coordinate point. And remember, you should be writing this as a coordinate, not just listing out, oh, here's what the x is, here's what the y is. Write it as a coordinate point because we saw on the graphs, that's what the solution actually is. It is a point. So I have my solution, but I'm going to check it just because I'm, a star student here and I recognize that mistakes are totally normal and they happen to everybody. So 5 times negative 6 plus 4 times 4, that'll be negative 30 plus 16. And negative 30 plus 16, that gets me closer back to the positives, right? Negative 30 plus 16 is negative 14. So I did it. But again, if you end up having to multiply both equations by something, that's fine. It doesn't mean you're doing anything wrong. Sometimes, like in example 3, you only have to multiply one equation. Sometimes, like in example 2, you have to multiply both. So you do have some practice problems. These directions here, right, it says you can choose 6 of the 12 to do. That doesn't mean the first 6, it doesn't mean the last 6, it doesn't mean you can only do 6. You can do as many as you want, but I think doing at least 6 will really make sure that you're getting this down. So thanks for checking in. And again, I miss you. I hope you're doing well, and please, please, please let me know if you need anything.